morning, guys. From now onwards, we will be moving on to the measures of dispersion. So, the reason for moving on to the measures of dispersion is that the measures of tendency, the central measures of central tendency are inadequate to give us a complete idea of distribution. So, we move to the measures of dispersion. So, dispersions are classified into two types: quartile deviation and standard deviation. Whereas quartile deviation deals with the terms of distance between the values, whereas the standard deviation deals with the terms of the average of deviations. Deviation is nothing but the scatterness among the variables or the values we're gonna do. So this is just a small theory part. I'm here in this video. I will explain all the formulas which are required for us to further proceed with the problems. So formulas. First one is the range. Range is nothing but the maximum value minus minimum value, that is x max minus x min. Second one, let's go to the second formula. Second formula is nothing but we'll be discussing about the quartile deviation. Quartile deviation. Quartile deviation has three points: 25% point, 50% point, and 75% point. So quartile deviation is nothing but we will classify the entire data into 25% will and 50% and 75%. So we will distribute the entire distribution into 25%, so 55%, 50% and 75% respectively. And from the percentages we'll be getting a insights of our distribution is. So the quartile deviation has 3 points. So the formulas will be like this: q1 is equal to L plus h by f into n by 4 minus c. This is for 25%. And q2 is equal to L plus h by f of n by 2 minus c. This is for 50%. And the last formula, q3 is equal to L plus h by f of 3n by 4 minus c is 75%. So by these three formulas we will be calculating the quartile deviation. So for the quartile deviation formula is 1 by 2 of q3 minus q1. This is the main formula to get the values from the percentages, accurate values from the percentages we have obtained before. So q2 is nothing but the median formula. This is nothing but the median. Just remember it. We will be using this formula mostly in our problems further. So we have gone through range, quartile deviation, and next let me move on to the mean deviation. Mean deviation is nothing but if f of I or f of I where I is equal to 1 to so on is a frequency distribution, then mean deviation from mean is given by, so mean deviation can be denoted by x bar is equal to 1 by n sigma f I slash xi is equal. So mean deviation formula x bar is equal to 1 by n sigma fi f into or fi of into mod xi minus x bar. So let me move on to the standard deviation. So standard deviation is denoted by Greek letter it is a positive square root of arithmetic mean of the squares of the deviation of the given values from the arithmetic mean. So the frequency distribution f of I will be given as Greek symbol standard deviation is equal to root of 1 by n sigma I f of I of x minus x bar whole square, not whole square, only for the x minus x bar square. So this is the standard deviation. So calculating variance is nothing but the square of the standard deviation. So variance is equal to standard deviation square. That is, variance can be given as 1 by n sigma fi of x minus x bar whole square. This is the formula for variance. So in another form, standard deviation can also be given as variance is equal to h square of 1 by n sigma fd square minus of 1 by n sigma fd. So this is the formula for variance in another form of standard deviation. So let me explain all the formulas. So range is nothing but the x max minus x min, where x is the distribution, you will be having the midpoints, so no problem. Quartile deviation is nothing but the splitting the observation into 20%, 50 and 75% respectively. And quartile deviation formulas for 20% is q1 is equal to L plus h by f n by 4 minus c, where L is the lower limit, h is the height, f is the frequency, n is the sum of the frequencies, c is the cumulative frequency of preceding median class, and qt is nothing but the median. Last quartile deviation can be calculated with the formula 1 by 2 of q3 minus q1. And coming to the mean deviation, 1 by n is the sum of the frequencies, xi is the midpoint value, and x bar is the x bar will be here, x is the midpoint, x bar is the median, will be find later. So coming to the standard deviation is denoted by Greek letter root of 1 by n. N is the sum of the frequencies, f is the frequency, x upon we will be getting from that, no problem. So variance is the square of standard deviation 1 by n f of x minus x bar whole square. So in another form, standard deviation can also be described as sigma square, the square is equal to h square of 1 by n sigma fd square minus 1 by n sigma fd whole square. So these are the main formulas required for us to solve any problems in the measures of dispersion. Thank you.